Hey guys, so in this video I'm going to be taking a look at the Sungold 7.6 kilowatt hybrid inverter. And in the past I've looked at other inverters, some for them, some for other people, where they call them hybrids, but they're actually off-grid inverters. But this is a legit hybrid inverter. So this does come with CT, so you should be able to do everything you can do with a hybrid. So share loads with the grid, self-consumption, all that fancy stuff. So since we started with that, I'll continue on with the AC side of things. This is a 7.6 kilowatt inverter, like I mentioned before, which should add up to around 31 something amps of output. Looks like the pass-through amperage on this is 50 amps. I need to keep looking, but that's what I've seen at first glance. And then of course, because this is a hybrid, it's designed to pull from the grid as well. So after you exceed that 7.6 kilowatts, it can pull from the grid to even out those loads. And then on the DC side of things, the max PV voltage is 600 amps, which is great. Another cool thing is it says the MPP startup voltage is 70 volts, which is really low. Most of the time I see 120 volts. So it's 70 all the way up to 550 volts is the operating range of the MPPT. So that extra 50 volts at the top is just for some headroom for cold weather. The max solar this unit can utilize is 12 kilowatts, but it's not going to be difficult to get to that number. Each MPPT can be paralleled. I believe the first MPPT is 40 amps, the next is 25, and then it's 25 again. So you've got 3 different MPPTs in this thing. Each can be paralleled and each can go up to 600 volts. So I could picture a lot of people over paneling this, having different arrays in different directions because it would be so easy to reach that max solar input. So if you have 3 inputs like that, you could have a nice size array facing east, another south, and another southwest, something like that. And then the max charging amperage is 200 amps. I believe it says something like 208 or something like that. It's right around 200 amps. So I'm going to mount the unit up on the wall first, then we can take a look inside, see what it looks like. So this is the bracket that comes with it, and I'll show you here in a minute on the inverter, but the inverter actually has these little bolts or knobs that stick out on the side. So there isn't anything that it's mounting on right here. It actually, on the sides of the inverter, it'll hook onto these little eyelets right here on the bracket. I do like the fact that they provide these lag bolts instead of wedge anchors. A lot of the ones we've been testing, and batteries too, they have those wedge anchors for masonry, but nothing for wood. So these are actually designed for wood, the ones they send with it. The manual calls for a 13-inch spacing in between everything on the side. We're not going to have that for testing here. And I don't really think it needs it. Based off what I see, the fans are venting upwards. So I don't know why they have that 13-inch spacing requirement. I've seen that on other inverters also, but these hybrids that vent upwards like that, it's really all coming from the bottom and going up. Oh yeah, not bad. All right, so let's start with the outside. This is the left side of the inverter. And these are those little knobs, these bolts that are sticking out that I was talking about. So that actually latches on to the bracket that you screw back there. Not as clean looking as we've seen on some of the other hybrids we've tested, but it works. Over here we have the PV disconnect. We have the 2 different latches for the door and then the on-off switch. Around the right side, not a lot to see, just the specs. Then when you open up the inverter, I remove this metal shield. So starting at the top left, we have a 300 amp battery breaker. Below that, we have the 2 positive and negative terminals here for the battery. And then focusing in here, we have dry contacts. These right here are listed as rapid shutdown. Then they've got some other ones here, probably for auto start for generators. I'm not sure what this connection is here yet. I need to look in the manual. Over here is where your parallel communications go in for adding more inverters. It says this right here is 485. That would be curious if that was for the battery communication. You guys already got a glimpse of it before, but here is all your different PV inputs. PV1, 1 and 2, PV2, 1 and 2, and PV3, 1 and 2. They can parallel here in the inverter. This is one instance where the little cover is going to help, but that's the generator input right there. Grid and output. So that would be considered your load. They call it a backup in this inverter. So that's grid input, that's output. So generator input looks like a 60 amp breaker, both grid input and then the output of the inverter are both 70 amp breakers. And then down below here is the actual terminals. So they've got the generator port right here. So the input for the generator port, but then they have a neutral on the bottom for the generator. Then they've got a neutral on the bottom for the backup, but then the neutral is up here for the grid. It kind of makes me think that they don't share a common neutral. I'm not really sure why they have it set up this way. It might have been a space crunch, so they didn't have space for the larger terminals in here. I'm not sure why they set it up that way, but I wonder if this neutral in the back shares a common connection up there with the grid neutral. I'm thinking it probably does. And then they have a ground bar here at the bottom. So everything on the outside is powder coated steel, which is fine. Like, that makes sense. There's a rubber liner over here on the door. That all makes sense too. What doesn't make sense to me is why they smeared clear silicone all in this seam right here if it's completely wrapped on the outside. Like, there is no seam on the outside. So that was just not necessary. So it's just not pretty. I mean, I appreciate they're going the extra mile right there, but that doesn't look the best. Okay, so the neutral from the grid ends right here on this board. You guys can make out those two white wires right there. The other from the generator and backup loads is right here, and it goes into the inverter. So I don't know, they might have some kind of ground neutral bond, some dynamic bonding or something like that in here. I don't know why they don't just have a common neutral setup and just have one common bar like we see on a lot of the other inverters now. All right, so I'm starting to pull wire through now, so for grid and for the load terminals. And I must be blind, but they give this little schematic that comes with it. It's actually neat. It's like a quick guide to the inverter. Good idea, really. But if you look from underneath, there is BMS, so battery communication, and that is for the CTs right there. I don't know how I missed that before. It just looks, this actually is a good idea because all of your wire is going to be coming from down beneath here. So it's a good idea to put them like this rather than this. That way your wire doesn't have to curl around. So I actually like that, these terminals facing down. And Sungold sent these two rack batteries. So I actually thought they were going to be sending the other models, the black models that are just a standard rack battery, but these are the heated versions. So these are self-heating batteries. I'm going to need to probably pop these open in another video just to do a specific review on these themselves. Anyway, I'm paralleling between these two batteries so I can have enough amperage to run this inverter maxed out. And then from this, they only have one terminal each, but it's a big, fat terminal. So you could fit, looks like you could fit a 4-aught on here if you needed to. But I'm going to put some 2-aught cable from these lugs right here up to the inverter. You can see here, it's pretty standard overall for some other rack batteries. Nice folding handles. Slick looking battery overall. No breaker though, which is a bummer. So I wish they had a breaker on these. At this point, I think all the batteries, rack batteries, should have breakers. And this, it lists in the manual, I think it's some kind of, you could put a Wi-Fi connection onto that. Anyway, this is the dip switch configuration it recommended for Sungold inverters. So we'll check it out here in just a minute once we get everything cranked up. So for input and output, I'm going to be using 6-gauge wire. That's a bit overkill for this inverter because of its rated capacity. So you could use 8-gauge wire. I'm sure they specify it in the manual also. Always best when looking at your inverter to see what would be worst to wire in and do that first. So the grounds were what I did first, and we're going to work our way through the neutral, and then we'll actually put the wires here. The temptation is to always do the thing you see in the front, and then imagine trying to get to the back part. This is an interesting layout because there's plenty of room, but then there's not. Everything is sort of cramped, especially if you're coming through these knockouts down here. If you're getting to the ground there, you don't have a bunch of room. 6-gauge wire was giving me some grief trying to get it in to the terminal. So I'm going to be using ferrules on these. We'll hook solar up in a little bit. For now, this should be the load breaker here. So once I turn everything on, this should be hot. Let's hope these batteries have a pre-charge resistor in them, so I'll turn the breaker on the inverter. Then we'll turn this battery on here. Oh, sounds like the inverter cranked up. Switch this one on too. All right, so we've got an alarm, and I'm pretty much going to guarantee that is lack of battery communication. It's pretty much the case every time I start an inverter up now. So the easiest thing would be to plug in a Ethernet cable right into battery communication and hope that that fixes the issue. Hopefully it doesn't need some kind of special pin out. Let's see if that works. So I'm going to assume link out means CAN port, since nothing's actually labeled CAN. And then we're going to hook into our newly discovered BMS input here. All right, so the first alarm, it was showing that the grid isn't present. And now it's blinking here for the battery, so we do need battery communication. And there's no buttons. Irritates me to death. So I have to hook up the wireless dongle now and see if we can get something working here. So this little plate is on the bottom. If you look in there, that's where you plug in the wireless dongle. All right, so this is a bit of a bummer. I can't do anything on the app itself. I'm locked out without administrative access, and I don't have that password. So I'm gonna have to email Sungold, see if they can send me that, because I can't make any meaningful changes on there until I do that. Looks like there's a bunch of settings. All right, so they gave me the admin access password, which is super admin. I wasn't gonna be able to crack that code. Also, when you sign in with the app, you can change the battery parameters. I'll try to show that here on the screen. And I chose Pylon Tech. It was set to lead acid. I chose Pylon Tech, and you guys can probably see here it is showing the correct battery percentage now, 47%. So we're good to go there. I've got a lot of different options to go through on the app. These batteries do need charging. Before I do some load tests, I'm going to run some solar into here. See how easy these little clips work. I do have ferrules on the end of these already. I recommend that to everybody anyway. The good thing I looked again to verify, but yeah, positive is on the right, negative is on the left. That's another first. Actually, I think I've had that on one other inverter. That's sort of rare though. All right, we should be able to switch the PV on now. That should light up. Oh, there it goes. And then when you push the power button briefly, the screen comes back on. So it should show solar over here. Let's see what it says. $20 watts. Let me look here online. So it does have plenty of solar, but it's only using as much as it needs. In other words, I think it's doing like 800 watts to the batteries, but it's not charging that much. And when I run a load like the heat gun, it'll pop up to 1500 watts or over and then go right back down as soon as the heat gun's off. So there's something to do with the charging. It's not charging the batteries properly. There we go. I changed it to lead acid and it is charging. We're over 2100 watts of charge on it now. Not making any noise though. It's there's a little itty bitty fan right here. You can occasionally hear that. Otherwise though, no fan sounds at all so far. One thing I haven't done yet is check the idle consumption. So we're gonna look here. I think it's 53.1. Yeah, 53.1 volts and 1.2 amps. So around 63, 64 watts. So not bad at all. All right, so let's do a quick output test. Like I mentioned in the past, hybrid should at least be a decent off-grid inverter because you never know when the grid's going to go down. So let's see if we can get that full 7.6 kilowatt output out of this inverter. All right, so we're right at 5.5 kilowatts. That noise you can hear behind me is the charge inverter. I'm using that for a dump load into the other batteries. This unit has still not, the fans still haven't turned on. And we're almost at 3/4 of its, well, we're a little over that, right? We're at 5,500 watts out of a 7,600 watt inverter. And the fans still even aren't on yet. So dead quiet so far. Let's see if we can add that 2,000 more watts and see what happens. There we go. So 7,700 watts. Again, 0 fans. Somebody's wanting something that's quiet. This would be it. There we go. The fans finally kicked on. At least we got the fans to turn on. Let's see if we can get a little more output out of it. All right, so we're showing 8,100 watts on the unit right now. So far, it hasn't had any issues. It did have to turn the fans on to cool itself. But it says L1 and L2. What was that? 3,600 watts on one. You have to wait for it to come back. That's always what irritates me about these type of screens. You're just waiting for it to scroll back around. You do have the online app. So we got 3,600 on one, 44 on the other. And it's showing 8,100 watts. Well, I guess we better crank it up, see what the limit for this thing is. There we go, 9,000 watts. So we got 9 kilowatts. They do not have a timed rating on their overload. So I don't know what, it says we got 4,300 on one leg, 44 on the other. So yeah, we're down to 8,800 watts right now. It appears this thing can output a lot more than 7,600 watts. Maybe it's temperature rated, so when we reach that max temp for long enough, it's going to shut down. I don't know. By the way, I haven't mentioned it yet, but this, I'm attached to the Bluetooth right now, but because I'm not using the Wi-Fi, this comms thing flashes all the time, which is irritating. There we go. So, I don't know how many minutes that was. We were over 5 minutes on 8 kilowatts, and then we were at 9 for, I believe, 2 minutes, and it shut down. I was going to try to get a little bit of the fans, a sound of the fans without noise canceling, but they shut off already. But when you shut this door, because most of the fan noise is that little one at the above this compartment right here, when you shut the door, you really can't hear it hardly at all. It hasn't restarted itself yet, but as soon as it does, we're going to do a single leg test next. See how far we can get up on a single leg, see what its load balancing is like. 3,500 watts on L1. So let's get something to tip it over the edge. Let's see if we can get 4,000 or 5,000 watts and create a real imbalance on this inverter. Okay, 4,600 watts on one leg on L1. Yeah, well, that's really good. I gotta say, I'm a little surprised. I didn't think it would do this well on load testing. It's doing a really good job. So 4,600 watts on a load imbalance is good. We're 1,000 watts over what it should be doing on a single leg. All right, it just kicked out. So it did around a minute at 4,600 watts, 1,000 over its single leg rating. So actually really good. Really good. All right, guys, so wrapping this up, I'm going to start with the pros first. So starting with price, this is pretty affordable. So it's in the mid 2,000s, I think. I've seen it from 2,400 to 2,600, something like that for this inverter. Basically anything you'd want to do with a hybrid, it can do. It did great on our load test, does good with line balancing, really quiet. It can run above its capacity for quite some time. It's relatively small. I can put the measurement of the inverter on the screen here, but yeah, it's not a large inverter and you still get 7.6 kilowatts and you can parallel it. So if you wanted to get 2 of these, again, price-wise, it wouldn't be too bad. You could get a 14, what would that be, 15 kilowatts. I was trying to add it up in my head, but 15 kilowatts of output, just a smidge over that if you got 2 of these in parallel. And I guess the cons would be mostly software related, other than not having a screen. Like you do have a screen here, but you can't change any of the options. And I really don't like that. That bothers the poop out of me. I didn't mention it before, but the generator port can be used for AC coupling as well. You've got time of use settings. You've got basically all of that in this inverter. A lot of people are only using the monitor page. So even with the EG4 inverters that I've reviewed in the past that I'm using now, a lot of people only use the monitor to change options. I'm not one of those people. I like to have the option of a screen here to be able to change things on. And even with the Flex Bosses, I use the optional screen that you can buy. And I mostly change everything with that still. I guess I'm old school in that way. Anything you change on this inverter is going to have to be done through that monitor page that comes with it. And that, I think, needs work with this inverter because there's a couple different things. It seems like it's tough to navigate. It should be done in groups, in my opinion. So if you've got an AC coupling category, it really should all be right there. And it's a little sporadic. There's some different options that shouldn't be where they are, in my opinion. And there's a lot of options on hybrid inverters. So it's not just this inverter here, but all hybrids are going to have a bunch of options. I mean, that's part of having a hybrid. You've got to have disconnect times, voltage times, all of that. There's a bunch of things. AC coupling, when you add all those options together, it's a long list. It could be possible that you can get solar assistant with this inverter. I didn't even check into that. They have a long list of inverters they work with at this point, and they stay up on that, so it probably can. A lot of people end up going with solar assistant rather than the software that comes with these inverters. And that's not just these, it's the NHX behind me here. People will use it for EG4 inverters as well. So like I said, in my opinion, I think the software needs work. The setup guides were actually really nice. I used Bluetooth connection with this inverter basically the entire time. I attempted to hook it to Wi-Fi in the beginning, and I was getting some complications, so I just hooked direct to it during all my testing. I'm sure if I stayed with it, I could figure it out. It didn't seem that difficult. I just didn't have the patience for it or didn't care really because I could see everything on the local connect option. Also, in self-consumption mode, it was feeding back. So I am feeding power to this from the Grid Boss, from my other inverters, since I don't use grid. So I was feeding grid to the unit here, and it did show that at some points it was feeding back around 1,000 to 1,200 watts, right around 1,500 watts at one point. So I didn't check that with a clamp meter. It could have just been the software itself reading that. I'm not sure. So like I said, that part is a bit of a mixed bag. I think software-wise is where its weakest link is. I think hardware, it's not bad at all. And maybe the software could be mitigated if you're using Solar Assistant. I mentioned the quick guide already, but the quick guides for setting this wireless dongle up for the inverter itself, those are actually really helpful. A separate pamphlet to kind of give you an idea of the layout of the entire inverter, and then just the initial setup. That's a good idea. The manual was really detailed in a lot of things, and again, I think it sort of was lacking in describing how to change different options in the inverter itself. Again, I know some of that is because it's a hybrid and there's just so many different things you can do with it. You can't really tie into each scenario, but yeah, I think that could use some touching up as well. Oh, and battery communication. I went into it a little bit in the video. I guess it's hooked up correctly. I'm going to keep messing with the dip switches, but for most of the video, I just used it in lead acid mode. It worked fine. So that's easy to change. That was easy to find in the options here. But I need to keep looking into it. I'm thinking I'm onto something with the Pylon Tech, and it is showing the percentage, but it was throttling the charge limit. I'm not really sure why. I guess in some sense, I'm spoiled with the EG4 inverters because I've got an idea of how everything works and the layouts with them and the menu options also. But even when it comes to the NHX over here, the screen options are very easy to understand on this. If you guys watched the video I did on this, you can go through each category, and the category has everything you need to see within that category and all the little subcategories that lead off of it. So again, with a screen that big, you can go into anything that's related to battery, anything that's related to communication or time of use. All of that is all on the one screen there. So I prefer that type of layout. Anyway, guys, I don't want this video to get too long, so I'll leave a link in the description to this inverter here. And feel free to add any questions you have on it down below. Thank you for watching, and stay tuned.